Oh, nice. Covered a lot of stuff you talked about. Okay, good. Good. I'm glad that what you're learning here is helping. Awesome. So yeah, today we're actually going to be talking about one topic only, but it's a pretty lengthy topic and also pretty important. So yeah, let's dive into it. So we're going to be talking about access control today. Access control is basically this kind of stuff. So you'll see here, we've been talking, or actually we haven't been talking a lot about this, but I kept telling you in previous workshops, oh, when you see pub, just ignore it. When you see access contract, right? Like these are all things that we haven't covered yet, and I was putting off until today. I'm actually curious, did you guys cover access control or access modifiers during Josh's session? So I can see if you guys already got intro to it or not. Oh no, okay, cool. Yeah, so this will be new for you then. Um, so yeah, so I guess in like a normal contract, right? When we had hello world, usually you have variables like this. You have pub let greeting be a string, and then maybe you also have then you initialize it, right? So I'm not gonna actually initialize it, but you initialize it here. Then you also have like a pub function change greeting, right? And then you pass in like a new greeting that's a string, and then it does some stuff, right? Well, all of these things that you're seeing here, pub, these are what's called access modifiers. And actually, there's a lot more of them. There's also access contract. There's also access self. There's what's called a private. So there's actually a lot others that we can do. It's just that so far we've only been, I was just saying to ignore it and just to always put public. But that's going to change pretty soon. So there's actually a really helpful diagram that I can share with all of you that goes over what all of these access modifiers actually do. So one of them, and ignore the right side for now, so don't look at functions, just look at this left side. You'll see that there's for every row, there's a declaration kind, which is there's two types. There's let and var. Now remember I taught you that in Cadence, when you put var, that means you're allowed to change the variable. So let me show you like what this means. If you do self.greeting right equals hello, and then that way we get rid of the errors. And then let's make a function called change greeting, and we say self.greeting equals new greeting. This is fine because it's var, which means that we're allowed to change this. However, if we say pub let greeting, that means it's a constant. And so now you'll see it says cannot assign to constant member greeting because it's a constant. That's really important when we take a look at this diagram because you'll notice that for each row, there's a read scope and a write scope. The read scope is where you can read that variable, and the write scope is where you can write that variable. However, based on what I just taught you, right, let is a constant, so it never has any write scope. So you'll notice that the write scope is none for all of the let rows because again, it's a constant, so it doesn't make sense to be able to change it. And the read scope is actually exactly the same as it is for the var variables. So for the sake of this lesson, we're actually going to completely ignore all the let rows because it's the same as the var rows, except there's just no write scope. So if you understand var, then you'll perfectly understand let. Okay, so let's just take a look at these var rows right here. So first of all, what we've been learning so far is pub. So you'll see here pub. This is actually the same exact thing as access all. So when you write a variable like pub, this is actually the same exact thing as writing access all. So don't get confused when you see this one. it means the same exact thing. And in fact, on the playground, when you go ahead and look at contracts, you'll see that sometimes they actually write access all as like the default. I always think it's a lot easier just to write it as pub, just because it's a lot shorter, but it's the same exact thing. Um, so the read scope is all. Now, this is where things get a little confusing. What does it mean for the read scope to be all or the write scope to be current and inner? These are confusing terms, but I actually have set out a whole diagram to help you understand what these things mean. So let's take a look at this diagram right here. This is what's called all scope. Um, let's say we have a variable, right, called public let variable A, and it's inside of some struct that's inside of some contract. So what I've defined here, like if we look at these boxes, there's a contract, then there's a struct, and then there's a variable and a function. What this is doing is essentially, I'll try and copy it here. Um, let's say we have some contract, right? And then inside of some, or it's actually called hello world, so we'll call this hello world. And then inside of hello world, we have a struct called some struct. So let's actually add that here. Pub struct some struct. And then inside of some struct, we actually have a variable and a function. So let's make that. So pub let var a, and then we have a function, something. I'm not gonna like actually name it. And so we're talking about this variable right here, right? And where this variable can be read. So this variable, because it has all scope, can be read basically everywhere. It's pretty easy. So it can be read inside the function that's inside the struct. It can be read in the rest of the contract. It can be read in transactions and scripts. It doesn't matter. All scope means everywhere. So um, what we can do is let's actually take a look at an example contract I have that's sort of like a puzzle, and we can start to identify where certain variables can be read. Also, sorry, I'm like coughing on the side. My voice is so ruined. Okay, I'm back. Doing too much talking. But yeah. So let's say we have this contract called some contract. We have a struct called some struct, and inside that struct definition, we have here we go, public var b. So this is again pub. This var b is a string, right? So where can we read this, this variable? Let's see, can we read it inside of this struct function? If it has read scope all, what do people think? Yeah, we can read it in here for sure. So we can, let's just say, what can we read? We can definitely read variable b, right? We're just calling it variable b. So we can definitely read it in here. What about over here? You'll notice this is actually a totally different object, right? This is a struct and it's defined in the struct. Can we read it outside here in a resources function? What about over here? Do you think we could read variable b over here? Yes, we can. Boom. So we can read it over here. What about a function that's at the contract level? It's not even in a resource. Can we read it over here? Yes, yes. Thank you, Snowdot. We can also read it over here. And lastly, can we read it in the script? What if we wanted to read it outside here? Yes, we can also read variable b over here. So it's pretty easy. Read scope just means all, okay? Or actually, yes, sorry. I don't know what I just said. All scope means that you can read it everywhere. So if we take a look at this diagram again, um, that is the read scope for pub and access all. However, it has a write scope of current and inner. That's very different, right? So if we scroll down here, this is what current and inner scope means. So current and inner scope means it's at, like, if we think of the contract as a box, we think of the struct as a box and functions as boxes. When we say current and inner, that means that variable a can be read at the current level, which is everywhere inside the struct and everywhere within. So basically, all that means is that it can be read inside the function, inside the struct, right? We can't go outside of the box that it's defined in, because that's not what's defined in current and inner scope. So that's what that means. So if we were to go back and look at, that's the write scope of variable b, all right, of this case in of variable b. Let's take a look. So inside of here, right? Let's ask what can we write? Do you think we can write variable b in here if pub has current and inner scope? Yes, we definitely can, right? Because it's at the current or inner level. So, right, that's fine. Now, what if we go outside of that struct into this resource? What do you think? No, we can't. So we cannot write b here. Okay, great. Now, what if we again go into outside of that struct into a function in the contract? What do you think about here? Nope, can't write it here either. And what do you think about a script? No, we also can't write it here. The Snowdot is getting it perfectly right. Yeah, we also can't write it out here. Great. So we've covered variable b. That's a great job, Snowdot. So now let's take a look at public set. So this is a different one. And actually this is going to be what's on variable a. So variable a has public set, okay? So what does that mean? Well, it has a read scope and write scope of all. Very interesting. A read scope and write scope of all. So if we walk through all these examples again, do you think we can read variable a inside struct function? Yes, and just to save everybody time, these are all going to be yeses. So because public set has a read and write scope of all, that means we can read and write it literally everywhere. So we'll have to add it to all these different areas, right? Now this is sort of the trick question I love to ask people is can we write a over here? Yes, we can, although it's a script, so technically the answer is no. Because you can't technically write any, you can't write any data in a script because it just won't do anything. But in terms of access control, yes, we could technically write A over here. But I'm just going to get rid of it because it's a script, so it's sort of a trick question. Okay, cool. So we've covered now pub set, and then of course access all because it's the same. So now let's look at access contract. So access contract, if we go a little bit further, this is containing contract scope. So what that means is it's anywhere inside of the contract. So it could be in here, it could be over here, it could be over here, but it can't be outside the contract in scripts and transactions. So this is a much different one. So let's go back to the contract here and we see access contract variable C, right? That's a string. So let's go in here. Do we think we can read and write C in here? Yes, we can. Oh, actually, sorry. I didn't mean right. I think access contract. Um, right. So access. Okay, yeah. So access contract has a current inner and containing contract for its read scope. So let's just talk about reading for now. So yes, we can definitely read it here. We can also definitely read it here because again, we're in the contract. So everywhere in the contract is yes. We can also read it here and we can't read it in the script because it's outside the contract, right? So that's very simple. However, then let's go back to its write scope. So its write scope is current and inner. So if it's current and inner, that means that yes, we could definitely write C in the current and inner scope, which is this. However, here is no longer in the current and inner scope, so we definitely can't write it here. We definitely can't write it here, and we also definitely can't write it here because that's not in the current inner scope. All right, so we're starting to get a hang of it. Let's try and go to the next one. The next one is access self. Now, access self is actually kind of similar to private. So it's actually the same exact thing. So if you see access self, you'll see private. Although what's very weird actually is that you'll always see people like, you know how I said that access all and pub are the same? Um, Basically, every single Cadence dev uses public. So nobody uses access all. Everyone just uses public. However, for some weird reason, it's the opposite with private. So nobody uses private. They all use access self. So I'm not exactly sure why that is. It's just what Cadence developers prefer. So just in case that's like a I don't know, little tip for you all in case you're writing code. Everyone writes public, but no one writes private for some. Okay, so this is access self. Okay, let's test this one out. So let's try it. So read scope is current and inner, and the write scope is current and inner. So for variable d, there's not too much fun. That just means we can read and write variable d inside this function, inside area 1. However, we definitely can't, read or write it in area 2 or area 3 or area 4. All right. So now let's talk about, yeah, exactly, Raven. So now let's talk about functions. So functions are pretty similar, but they're for functions now. So instead of talking about where can we read and write them, we're going to be talking about where can we call them, right? So that's what's important for functions. So let's look at these three functions right here. This one has public func. So let's see what pub means. Pub means we can call it everywhere, right? All. So let's see. So yeah, yeah, so what can we call? So we can definitely call public func here. We also can definitely do that down here because again, it's all. So it's no question. Basins and also here. All right, pretty easy. Let's take a look at the next one, access contract. So access contract. Let's see, current, inner, and containing contract. All right, so that's pretty simple. Um, so we can definitely call it in here because it's in the contract. Definitely can call it here. It's also in the contract. Here is also in the contract. However, it's not in the contract here, so we can't call it here. Right, everything's script, exactly. And then here we have private functions. So private function has access self, which, let's take a look, has only current and inner scope. So, yep, this is definitely in the current and inner scope. However, once we go outside of this struct, or right, I like to think of it as a box. Once we go outside of this box, right, we can no longer call it over here. We also can't call it over here, and we definitely can't call it over here. So this is the final solution to this little quest that I was walking you guys through. And what I want you to do now is I actually want to share a playground. I'm going to share this exact link with you, except this time I want all of you to sort of take 10 minutes on your own and fill this out on your own. So go ahead, and if you can, copy this. If you're like if you're on a desktop or whatever device you're on, go into a playground right now and paste this into your contract and try and fill in all the answers that I just gave you. Um, but this time you're not going to have my help. So take a couple minutes, take like let's say 10 minutes or so, and you're gonna just do the exercise I just did, but on your own. See if you can do it. And also, here is a really helpful cheat sheet um, that you should always use with scope. So I'm gonna mute over here until, let's say, I'll give you 7 minutes, and wherever you are at 7 minutes, that's totally fine. We'll just regroup in 7 minutes. All right, I see Snowdot put a playground link in here. Take a look. So we have read and write, awesome. Read and write, awesome. Oh no. Oh, 1 more minute. Okay, cool, cool. I'll wait 1 more minute. No worries, no worries. All right, one more minute, and then I'll keep going. We're actually almost done anyway. Beta player on this buggy on save, yeah. All right, Snowdot is done. Boom. A bing but a boom. Got confused, to be honest? Yeah, see, exactly. That's what I'm saying. Like, even though you had it down, Snowdot, when we were doing it together, like, once you do it on your own, it's always another challenge. So that's why I wanted you all to try it on your own. But yeah, let's take a look. So let me see. Let's see if you got it right. So we got read, write, and func. Perfect. We got read, write, and this is all correct. Yep. We got read, write, and func. Yep, this is also correct. And lastly, we have read, write, and polyfunc. Nice, 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 nice. Great job. All correct. With the only caveat being that this one is like technically correct, but also a trick because you can't really write anything in the script. But yes, it is correct. Just like a little side note. All right, so great job to Snowdot, and I hope all of you were able to find a similar level of success. So the last thing I want to talk about is actually this access account one. We skipped over this one. The reason we skipped over access account is because on the playground, it's not possible to show it. The reason for that is because access account, you'll notice, is very similar to access contract. It's current inner, except instead of containing contract, it's other contracts in the same account. So what that means is it's the exact same as access contract. The only difference is that you can also access it in other contracts in the same account. The problem with the playground is you can only deploy one contract per account. However, in the real world, that's not the case. We can actually see here if I pull up this account on mainnet. This is the account that is holding all of the Flovitar contracts. Um, yes, I believe the Discord stream is on. Are people able to see it? Okay. Yeah, and I'm not sure why it's not showing up for you, pal. Although this is being recorded in case. No, yeah, no worries. Let me actually try to restart it for you. Hopefully that works. So this is the Flovitar contract, or this is the Flovitar account on mainnet, and you can see that this one account has all these contracts inside of it. So unlike the playground where you can only deploy one contract per account, in the real world it's actually like this. So you'll see that what access account would let us do is let us access some variable or function in any of these contracts, but not in contracts in another account or a script or transaction. So that is the main difference. And let's actually try and see if we can search for an access account. I don't see one in here. See if we can search for one in here. Nope. In here, maybe. I don't think there's any examples, but actually, let's try float, actually. I think there might be some in float. Oh, no, I guess it, oh, wait, access. Oh, I do, okay. So in the float contract, there actually is some access account. So for example, oh, look at this variable. So right here, the float event keeps track of who currently holds it, and it has an access account modifier. So we would be able to access this variable inside of this whole contract and inside of these contracts. All right. So that's that. Also, want to make one really important note. I say this a lot, but I just like to, confirm it. And it's also in the Cadence course here. It says, after looking at our access modifiers, we must make an extremely important distinction. Even though some access modifiers like private make fields unreadable in your Cadence code, this does not mean people cannot read this info by looking at the blockchain. Everything on the blockchain is public, regardless of its read scope. Access modifiers simply let you determine what is readable/writable in the context of your Cadence code, never store private information on the blockchain. So even though I could technically make a contract that does something like this, that does like a private let password, right, and say self dot whatever password equals hello, and I deploy this, and you'll say, oh, Jacob, it's safe because in my script I can't read it, right? I can't say import hello world from OX2, and then return hello world dot password, which is a string. You'll say, oh, it's safe because we cannot access password, so it's not gonna, it's safe. No, that's not true. I could technically still go to the blockchain, analyze the block data, and find this out. So don't get tricked into thinking that this makes things private. It's just in the context of Cadence code. So with that being said, that's all I have for you today. That was access control. And during tomorrow's workshop, which is remember our last workshop, um, although to be honest, I'm not really sure how I'm going to stream that because I'm not going to be home. So I'll have to figure that out. But if we do have a workshop tomorrow and it doesn't get canceled, we will basically finish our NFT contract, and that will be it. But that's pretty much all the concepts I wanted to teach you during this whole boot camp. So if we do have a workshop tomorrow, it's not going to be anything new. It's just going to be sort of reaffirming all the concepts we've learned. If you want to check out this course, again, I strongly recommend it because this contains so much information about Cadence. Check that out. But other than that, yeah, that's the majority of this boot camp. So I hope you've enjoyed it so far, and thanks for tuning in. Yeah, you're very welcome. Also, in case any of you are wondering, I also made a whole YouTube video on auth account capabilities and walletless onboarding. So, if any of you are thinking about exploring walletless onboarding for the Flow Hackathon or the new auth account capabilities feature in Cadence, you could definitely check this out also. Pretty good video. All right. With that being said, enjoy the rest of your Thursdays. Enjoy the weekend, and good luck in the hackathon. I will be judging your submissions. Haha. GG, well played. Peace out, everybody. Bye.